So today we're going to be talking about MySQL. Quick outline. First, we're going to talk about the description and motivation, and then we're going to move on to use cases and examples and comparisons with alternatives. So basically, what is MySQL? It is one of the world's most popular open source database management systems with a client-server model, and it's used by big companies such as Facebook, Twitter, YouTube, and Google. It was created in 1994 by a company called MySQL AB. MySQL stands for Structured Query Language, which is basically very useful in handling structured data that in like tables that has relationships between entities and variables. It is classified as an RDBMS, basically a relational database management system, which is the same thing where data is stored in tables with relations between the tables. And it's open source, which means it's free to use and it's possible to learn how to modify the code for your own uses. So MySQL basically is consisted of three types of languages. There's the data definition language where you can create the database and all the data that you need, and data manipulation language to modify and query the data, and then data control language basically to grant permissions to users to access the data. Its popularity is due to its flexibility and its ease of use, and the fact that it is generally the industry standard with lots of resources and rapid development. And on top of that, it is secure. MySQL uses the client-server model where clients are computers that have MySQL installed and running, and then they connect to the server where the data is actually stored. And then when they actually need to use the data, the clients will make requests through their GUIs, and then the server will respond to the request and it will appear on the client side. Our motivation for choosing MySQL was that we wanted to research one of the most popular and widely used DBMSs, and we wanted to have a good understanding of how it works in case we ever use it in future. So there are quite a variety of cases where MySQL is used, including data warehousing, e-commerce, and web databases. For example, Facebook uses MySQL to manage its large amounts of data, and it uses it in addition to InnoDB to manage activities such as likes, comments, and shares. YouTube stores the videos in a file system, but it uses MySQL to store all the data related to each video, including user preferences, advertising information, and country customizations.
Now, to install MySQL, it can be conveniently done on multiple platforms. On Windows and Mac OS, it's very straightforward. You just download the installer from Oracle's website. For example, here. On Linux, there are many installations methods, but the most popular one is using the yum repository, which is also maintained by Oracle. So basically, you download the package, run this command, and you can get the installation started. Now, what's important is during the installation, there will be configurations, and we'll be talking a few important points here. First is that for our purposes, we need to choose both the full installation option, which will give us both the server and the client. Now, the server includes the MySQL server, which will allow us to host our local server and connect to other servers. And the client includes tools like Workbench and Shell that will allow us to manage the databases in the MySQL server. Now, after this, the other two important parts is that when during our installation, we'll be prompted to set up our local MySQL server, which we'll also call the local host. Now, the first image here is pretty much the default settings. We'll be hosting a server on port 3306. And the second is actually important. So when we install MySQL, we actually create a root account, which is also the default account that we'll be using to access our MySQL server. So choose a password you can remember. Now, there are additional learning resources online. Oracle provides a very extensive documentation for MySQL. And also the language MySQL uses, the SQL language, is also very popular. You can find tutorials on Code Academy and other places. It's very easy to find. Now we'll start with a simple example. So as I said, two clients are installed when you use the full option, both the Workbench and the Shell. Now the shell uses command lines while the workbench uses a friendly GUI. Now we'll start with the shell. To use shell, we'll first connect it to our server. Now here's the command that I typed it in. Connect root localhost 3306. This is connecting to the local MySQL server we just created during our installation. From now on, we can start to use MySQL commands to access the databases inside our server. Now, when the local server is installed, a database called Sakila, which is a sample schema, will also be created in the local server. Now, to access this sample database, I'll type use Sakila, which will now switch the current schema to Sakila. Now, from now on, I can also do things like create table department, which will create a new entity called department with an attribute called dname and whose domain is varchar20 in the Sakila schema. Now, all of what was previously talked about can also be done in Workbench much more easier. So to connect to our server in MySQL Workbench, basically all you need is click this button right here, local instance MySQL, and it will connect us to our local server. Now, then you'll be greeted with a friendly interface with a place to type commands, the output, and a sidebar. Now you just put the two previous commands, use Sakila, create table, department, and it will do the same thing as we previously did. Now, we'll start to use MySQL Workbench. In Shell, you can use the command called like select first name from actor to get all the first names of actors in the Sakila schema. Now, we can also do the same thing in Workbench. We type in the same command and it will show you all the names of the actors in a very friendly GUI way. Now, but we can also just right click on the actor in the Workbench and there will be a prompt where it will allow us to just show all the names. And yeah, it can be all done in a friendly user face. Now we'll attempt to create a new schema in our database and put some entities in it. So here's the code. We'll first try to create a schema called test. So create database, if not exists, test. We will then use test. So switch the current schema to test. Then we'll create some entities. We created department, create department locations, project, works on, and we also put different attributes in them. And in here, after we execute this code, we'll see the output in the Workbench. It will tell us it successfully created the table, the schema and the table and the respective attributes. Now, what was just done will also be reflected in the sidebar of Workbench. So in the sidebar here, you see we have the Sakila database, which is the sample database, but we also have the test database, which is what we just created, and it has three entities. I mean, department locations, project, and works on. So 4 entities. And I also opened project, and we can see the attributes p name, p number, p location is also in there. So it is all accurately reflected exactly as I typed in the command. Now, the best part of Workbench is it allows you to create entire schemas with predefined entities and relations. To do so, we can use the modeling tool. And here is an example interface. We are viewing the Sakila model. We can also use the Sakila model by using to create new schemas. So I create a new schema, and then I'll use the function called reverse engineering. Using reverse engineering, I will be able to pull all of Sakila's entities and relations here and put it in my new diagram. So here is the result. I pulled everything from Sakila, things like film, language, inventory, film actor, and all of its respective relations and attributes. We can also create new schemas using the modeling tool, in particular using the add diagram function. Now here I created a new diagram with 5 entities, and I have gave them relations, which is specify their foreign keys, and also gave them their respective attributes. Now, to use what I just created, we can use a function called forward engineering. By forward engineering, the program will inspect what you just drew, and then automatically generate all the code needed to create these data to create the schema. So using the previous diagram I created, I forward engineered, and here is the code automatically generated. By simply running this code, you'll be able to get a schema exactly as you drew in the diagram.
So the last thing we're going to talk about today is comparing MySQL with a couple of other things. First, it's going to be SQL, just the language, and then later it's going to be MongoDB. So the difference between SQL and MySQL is that SQL is just the language that you use. It doesn't actually host the database, whereas MySQL has all the information stored in it. SQL is much more secure, and that's because it doesn't have open source, and it has very few updates. So the updates that it has are very thoroughly checked over by by Oracle, who works on it. MySQL is updated much more often, and it is open source, which means that bugs that are there in the code can be found and patched out quickly because of users who report errors, and they're able to help fix that. And then MySQL also handles many storage engines, removing the potential bottleneck of if you only have one storage engine, then everything has to go through that. SQL has a separated server versus database so that operations can continue while the data backs up, but MySQL specifically disallows that for the sake of increased data accuracy and decreasing corruption during said backup. SQL is also oriented towards skilled users trying to do advanced operations, whereas, as you saw from what Jingyu presented, the MySQL workspace is much more friendly for less skilled users and beginners. And MySQL also allows third parties to modify data, which helps with other companies trying to run applications on your database. So now, instead of comparing with the language, we're going to compare two different full relational database management systems. So MySQL versus MongoDB. MySQL uses SQL, as the name implies, whereas MongoDB uses JSON files. And MySQL uses schemas, which means that all the data all of the entities have to have the same attributes, whereas MongoDB does not use schemas at all, meaning it's not enforced. And MongoDB natively supports replication and backups. In case the primary database fails, you can automatically switch over to a secondary database. So a company called Panoply has created this useful table for if you're starting a company and trying to figure out which one between the two of them you'd like to use, the advantages and disadvantages. So overall today we talked about how MySQL is a popular relational database management system. It's used by Facebook and YouTube, and it has advantages of being the industry standard due to its use flexibility and regular updates. And it uses a client-server architecture with support for multiple server storage engines, which increases flexibility and scalability. And here are some references that we used.